Welcome to our webinar. Very, very excited today to be talking to you about VLANs and BBMDs. Of course, I'm not going to be doing most of the talking. We will leave that to our wonderful presenters, Robert Lastinger in the technical support team at Distech Controls, and Dave Cousins on the product team at Optigo Networks. Robert and Dave, it's over to you.
Great, I'll take it from here. So agenda-wise, we have three main topics, and these are gathered from feedback from some of our previous webinars. We're going to try to spend about 15 minutes on each, really brief slide show for each, and then we're going to go into the actual practical application and show, you can see one of the cameras is on Robert's rack, and it's got all of these devices in it, and we're going to be going through a live run-through of some of the different applications. And as you may notice, my voice was a little bit sketchy today. I'm just getting over a flu, so I'm apologizing for that now. It may happen, it may crack a little bit as we go. So what we're going to start with is in our previous kind of live setup, we didn't have any MSTP devices set up, and so we were purely working on Ethernet and IP over Ethernet, and we want to talk about how MSTP works with BACnet as well, because it's quite a few, quite a large amount of those devices set up in the network. So just to briefly go over what MSTP is. So MSTP simply stands for Master-Slave Token Passing, and it covers the physical and data link network layers. So that's kind of the bottom layers where everything else is built upon. And so MSTP, for example, has its own connectors, and this is an example of one right here. It has its own wiring as well, and it basically what happens is the master devices within the network pass a token around, one to each, and that's part of the messaging protocol that makes up MSTP. The device that has the master device that has the token is the one that's allowed to broadcast information to the network. And so that gets passed around the network, many times per minute, and each device gets to have it say when it's its turn. Typically, this is mostly used in a daisy chain and or a ring format, not typically used in a home run. It doesn't make any sense. Now, one thing of note is it doesn't really have a layer 3, which is where the routing comes in and where you can connect different networks together. So usually MSTP networks are isolated. One of the things that has been developed over the years is a MSTP to BACnet to IP BACnet router. It's called a router, but it's really it's a translator. But we'll call it a router for that purpose. So it's basically taking the MSTP traffic out of that. Sorry, let me step back. All the BACnet traffic that's sitting on top of MSTP is getting taken out of that network and broadcast out into the rest of the network. So it becomes IP traffic at that point. So it's a transition point between MSTP and IP. Where you can pull BACnet together as a whole in your entire network. I'm not sure if I said that the best way possible, but we'll show you what that means when we show you some live traffic. And on this device, connector device, you can actually set up the MAC address for each individual device in the within the MSTP network. And so MAC address is what identifies it kind of at the physical data link layer, and then on top of that, BACnet, which sits on top of that, has its own device ID. So you have a device ID and a MAC address to identify each specific device on your MSTP network. All right. So let me just skip over this. So you've seen a version of this before if you've attended any of our webinars before. I'll describe some of the higher level stuff really quickly. On the left, you've got your router, so that allows us to talk to the internet. I'm able to VPN into this network that's at Robert's location via that router, and I've got a VPN set up. There's a network controller and a aggregation switch in there, and you can see that in the center top. And we've given that VLAN 100, which is basically a management VLAN. So we've separated the management traffic because we don't want to overwhelm it. And in the green, we've set up one big VLAN just to simulate throwing everything onto one network, or having all of our traffic in one place, and show you how that can be a problem. And we've got two switches within this configuration. They're both 4-port Optigo switches, the C401Is. And then attached to those, we have MSTP controllers and devices. And Robert will show you a little more what these look like on the rack and how they're connected.
So actually,
right.
we added the BACnet IP router. If you watched any of our last seminars, the BACnet IP router, it wasn't present, and I'm going to point to it now. It's right here. Most of you have seen one before, used one before, and that's the first one. And we're using the second one, which is incorporated into the S1000, which this was on the rack prior. It's right here. And the MSTP devices are sitting on a shelf behind the S1000, and they're wired directly into it. So just to add a little bit to what Dave was talking about prior, we're all mostly accustomed to MSTP devices and setting up an MSTP trunk. And that basically, on older jobs or in the past, that took care of your network segregation for you. You would have one MSTP trunk, and it was isolated from another MSTP trunk. And typically, you would bring those into some supervisory controller, and you might not even do peer-to-peer linking across them. But with the newer setups and a lot of IP devices, it becomes easier, especially at integration time, to have these MSTP devices able to talk at the IP level. And so it's creating some problems because the old way of having, say, two MSTP trunks and just throwing in a BBMD so that those two can talk, that worked well at that level, but it does not scale well at all. So we have a couple devices here that we're going to demonstrate why that's not a good idea. And we're going to add a little bit of traffic for you to see it. So we have here the S1000, which is what I'm showing on this screen. It has the two of the controllers, what we're going to basically consider our mechanical system, our air handler, or possibly your plant controller, whatever you want to talk about. We're going to have those on the S1000, and you can see they're doing a little bit of traffic right now. In fact, they're doing quite a bit of traffic for two devices. And then we have an IP router, which is right here. And this is handling the network with our VAVs. And we're going to consider this, for this seminar, we're going to consider this just our zone controllers. And they don't really have to talk to anything else. If the other ones are doing plant control, there's really no reason a VAV would need to talk to a chiller, for instance, or a boiler directly. Not normally. So we don't really need, although in our setup, and if Dave goes back to one view, we'll show here, we have these controllers. If you scroll down, Dave, we have these controllers, the IP routers and the IP devices are all on the same network. They can just talk to each other. They're on the same subnet and the same network. And we haven't set up the BBMDs between them because there's no need yet. They're not separated. But the problem with this is they're doing quite a bit of traffic, and any broadcast traffic, their global whoever, all of this stuff is being seen on the MSTP trunk. And so it's a lot of traffic for the MSTP trunk that it doesn't need to be aware of. And what we want to talk about today is how we're going to segregate that and what it looks like when we separate these out, and then how to bring that traffic back with a BBMD over a VLAN. And it's common. We want to stress really quickly that it's very common to look at VLANs and say, I have a Class C network, so 254 devices, and I'm just going to call that one VLAN. Or I have one floor, and I'm going to call that one VLAN. And that's not a great way from a design standpoint to look at the system. If you have tenants, sure, that might be what you have to do, but generally speaking, VLANs, we want to use those to segregate mechanical equipment or equipment that needs to talk directly to each other. And we want to segregate that from equipment it doesn't need to talk directly to. For instance, like a VAV and a chiller. They don't need to be on the same VLAN because they probably don't have any peer-to-peer communication that they need to use. So we want to talk about that your subnet and your VLAN are really two different things. So for instance, it's okay to have a VLAN that only has 6 devices and have another VLAN that has 210. That's not a problem. If that's what the system is set up like, and that's how the controllers, the mechanical systems are built, then that's fine. And you can have smaller subnets within those VLANs or bigger, but a VLAN can have thousands of devices or a few. And so when you're looking at how you want to do your VLAN and how you want to do your subnets, you're really looking at two different things. And so we really want to focus with VLANs. We want to look at the mechanical systems you have or the types of systems you have, and do they need to talk to each other? Because if they don't, they really should be segregated. That's important, not only for the health of the network, but just from a security standpoint. If they don't need to talk to each other, they should be segregated. So, and then we'll show you if you do have data that needs to cross VLAN, we're going to use BBMDs to get it there. And then we're going to talk about, at the end here, we'll talk about when and where we might use a BBMD and why they can be a good thing, but they can also be a very bad thing. So we're going to get into that. So on to the next step.
Great. So what we're doing is we have our capture tool, which we introduced last time as well. We have that connected into the network on this VLAN, and we're currently capturing some traffic. We want to show you an example of what that traffic looks like, and so it's being captured and uploaded. And when that's done, I'll get an indication, and we'll have a look at it. But in the meantime, one thing we're going to do is, so we are going to create these VLAN, and we're going to separate it, and we're going to show you that the VLAN, show you that the traffic on each VLAN is much reduced, and that the unnecessary broadcasting between them is gone, and we can probably start on that now. Do we have a capture to look at, or are we not yet? Okay. So what do we want to do first here? We'd
like to probably create the VLANs that we're going to move these networks to.
Right. Okay. So let's start with that. So we're going to create a new VLAN. Now, this tool, OneView, is part of Optigo's standard suite of networking tools, and within it, I can set up a new VLAN. As you can see, we've practiced this before, but this is going to be MSTP for that MSTP chain. I'll put a quick description that just says
this will be our let's just say our plant or AHU controllers, whichever one you want, MSTP1.
Okay, and I will add that, and I'm going to pick a color. Let's go for something bright green.
Now, while Dave's doing this, it's important to discuss, if you are setting up VLAN like this, and say an IT department has told you that they've added that VLAN and they're going to trunk it down to your Optigo network switches or setup, it's a good idea, if you can, to go ahead and create the static leases for your devices ahead of time. So in this instance, if I create VLAN 200, I can go in there in wherever my DHCP server is and give it those MAC addresses for those controllers. So that way, when I switch VLANs here in the interface, the devices will automatically pick up the correct address on the new VLAN. So it's not always as easy. It's easy to say that. I know it's very difficult to do that in practice. But one of the ways I do that is if I have a system with a few VLANs, on every VLAN, I'll put every MAC address and I'll give every controller an assigned address if the range allows for it. So that way, if I move them around, I never have to go back in there and adjust it again. In large network ranges, that's not going to happen. But in a small site, it's very feasible to do that. And we'll talk about that here right before Dave. In fact, if Dave will switch to my screen, I'll bring that up for you real quick. So here, this is the VLAN that all those controllers sit on now. And two of the controllers have reserved leases right here. So that when the VLAN is activated and they're seen on this VLAN, they're handed these addresses. So in this case, it'll be 51 and 52 respectively on VLAN 103. But if I go, even though we haven't used it yet, if I go over to VLAN 201 or 200, let's see where I put it. I think I put it on 200. If you go over to VLAN 200, you'll see I went ahead and created a lease for those exact same devices, exact same MAC address, and different IPs, 200.51 and 200.52. And the reason I do this is ahead of time during setup is so that if I move these things around, they automatically get an address on whatever VLAN I move them to. So if you're setting up the DHCP server or the static leases and you have a couple VLANs, consider setting up some of these leases ahead of time if you think you may be moving them around. Obviously, you could just wait for it to get an address, and you could use ExpressGFX to find it, or ExpressNet Utility to find it, or you could just look at the server and see what addresses it's handed out. But a little bit easier if you know what IP it's going to get ahead of time. All right, you ready to switch, Dave?
Well, I've got to finish up.
I already did the trunk port for you. Yeah, the trunk port's done.
Perfect. And then, and so we're going to move this guy here off
to 200.
On 200.
And 303 goes with it.
And yeah, we'll use this later. You can see it says BBMDs. We'll use that later when we're going to talk about BBMDs. Mm-hmm. So all I need to do is cycle these guys off, and I'll save changes, and we'll watch this. So this guy will come back on, or go offline, come back on.
Yeah. So what Dave's doing here, we want to anytime you switch VLANs, it's good to go ahead and cycle the port, because when the controller sees that there's no network connection, the connection will go down. And one of the things the controller does when a connection first comes up, most controllers, not all, but most, will typically ask for a new address just to verify. Some controllers won't. If they have an extended DHCP lease, some types of controllers or IP devices out there, they may not ask again. So you may have to power cycle those controllers to get them to respond. Newer things, most modern controllers will, if they see the network go down, when it comes back up, they'll ask for the address again. So, but just keep in mind, there's always potential. If you change these, you may have to power cycle a device or wait for the DHCP lease to expire. And so this is one reason not to have excessively long DHCP leases on a network. So a lot of times, if you look at your home router or one you set up on job sites, you'll probably notice the DHCP lease may say something like 12 hours or 24 hours or even longer. In a controls network, you never really want to have a DHCP lease go longer than 12 hours. The reason being, if you reassign addresses, worst case scenario, you come back tomorrow, everything's got the correct address. So you don't want to have a DHCP lease longer than 12 hours, but also don't make it shorter than, say, 1 hour, because then you'll create problems on the network. So 12 hours is a good number for a DHCP lease.
Yeah, good point. And so now you can see that these devices come back online. They're on VLAN 200 now, so which these are segregated from our other MSTP chain that we still have on our default 103. I can show you here some details. So, for example, once this does its polling, it will show us that we've got a fair bit of traffic going on this guy. There we go. So it's calculating the rates right now, but you can see there's quite a few frames that have been moved within this. Not as significant, but it's a good set of traffic there. And then on our other here, so we still have this much traffic on our existing chain that we left and we separated from. And so that, you can see there's still a fair bit of traffic there as well. So we've got traffic on both VLANs now. So we're going to have a look at capture next. So just to give you an idea of what the capture is doing, it's connected. This is the capture tool here. I showed you an example. It's not very interesting to look at, but it's interesting in terms of what it does. So it's connected into VLAN 103, and it's been capturing traffic all along. And basically, once it's done capturing, we upload it to our cloud-based visual BACnet tool, which analyzes it, and we can show you how that traffic has changed as we move the other devices off of this and onto the new VLAN, and it'll show our existing VLAN reducing traffic. So once that is up, it just takes a few seconds. We have Corey in the background, and he's updating it. So I'm going to go into that tool now and password in. All right, so we're going to load up. Basically, we've taken the capture and we've put it into a file here, and we're going to have a look at that. It's kind of slow right now, but here we go. So this is 846. That should be the one. No, okay, that's not the one. Oh, that's not the one.
Takes a second to get that data processed.
Yeah. Let me go back. And just to give you an idea of what this tool does, it uploads the traffic from the network. It goes through all the BACnet traffic in that capture. It's going to analyze a bunch of different things to see if there's any issues in your network. And then it's going to basically give it a network score. All right, here we go. Here's the new one. Okay, so let me show you a few things of interest here. So first thing, the only thing it really showed as flagging it is that we have excessive amount of broadcast traffic. In fact, all the traffic that Robert's sending from those MSTP devices is broadcast. So that kind of makes sense. This over here is basically both networks sending traffic, and then when we switch VLANs, we have just one that's sending traffic, and it's a nice, even, predictable traffic pattern. And
it's worth noting in this diagram or in this chart, you see the traffic remaining is just the zone controllers, and
yeah,
that's what the package. And so, and it stands to reason. You're going to have a lot of traffic if you have air handlers or larger mechanical systems, or you have a chill plant or a boiler plant. These things, there's probably going to be a lot of communication going back between the supervisor and other controllers. And so those networks tend to be a little busier. And you can see when we split it off, all of that traffic and upwards of 500 packets per second just on the MSTP side. I'm sorry, per minute on the MSTP side. That was all being seen by a VAV that had no business. It didn't need any of it. It didn't want any of it. It's just doing its job. And you're saturating an MSTP trunk for no gain. Or maybe possibly you need one network value, but you're getting all of that with it. So that's where VLANs become really nice for us to segregate these and allows us to route traffic correctly. But I'll let you continue, Dave. Go ahead.
Yeah, and I was just going to add to that in the case where you're pushing the boundary of your capacity on your network, for example, if you've got a 100 meg Ethernet port and you're plugged into that, if you're getting to the point like this is only 1,000 packets, it's not going to meet that. But in a real network where you have maybe a few hundred devices on that MSTP chain, you could be pushing the limit of that 100 meg with just one of these sets of traffic. So you could be getting into network lag, you could be getting into dropped packets, things like that, and you don't want to have that. So once you separate it into VLANs, your capacity of your network goes up, and you get a lot more capability to basically to build onto it, to scale it up, and it's more predictable as well. So you can see there's three sources of packets here. So one of them is the 60, which is the green one down here. That's that continuous, like even one mechanical, as Robert is saying. And then the other ones are a little more variable, the 51 and 52, and those are the ones that we've switched over to the other VLAN. So you can see how you get a really nice, predictable network usage when you do VLANs like that. And when you divide it by service in this case, because it's divided by service, that's really important.
And okay. I mean, before we didn't, these issues never came up before we really started, the industry started moving towards IP devices, because if we'd had separate MSTP trunks, if they were talking to each other, typically it would have been via some supervisory controller, and they really wouldn't have seen, unless you set up routing, they really wouldn't have seen each other's broadcast traffic and stuff like that. And so that's really what we're trying to redo again on the IP side, using VLANs to help us recreate that segmentation we had when we were doing MSTP.
Yeah, exactly. Okay, so we've kind of blended into our VLAN, but I'm going to zip back to the slides for a few seconds here. So that was our live demo. So we talked about most about this, so we'll touch on this, and we'll go back to talking about VLANs. So we talked about segregating. There's two things we just talked about: reducing the load in the network and separating the loads into different VLANs. The other interesting thing that you get is isolation for security purposes. As a note, this is not the security of your network. You still want to, if you're worried about it, you need to encrypt. You need to create encrypted tunnels and things like that. But if you want to segregate your more sensitive data into a separate VLAN, and somebody is sniffing on another VLAN or hacking on another VLAN, they're not going to see this traffic. So it is a little more secure. We did talk briefly about this, but I'll go into it again. Some of the best practices for creating VLANs. When you're designing your network at the beginning, you want to know what services there are and what things need to talk to each other. And that's extremely important in terms of how you design VLANs. You want to design your VLANs around things that need to talk to each other and things that are distinct services. So for example, if you want to do your CCTV or your alarms, your HVAC on separate VLANs, that's great because they don't need to talk to each other. So it's not necessary for the traffic to be combined between those different VLANs. There are occasional reasons why you want to do that, and that's where BBMDs come in, and we'll talk about that one in a second as well. So, and another way of looking at kind of non-service view of it is maybe you're a building with a bunch of tenants, and you want to segregate each tenant, and that's easy enough to do as well, because obviously their traffic it talks to each other, but doesn't need to talk to other tenants. And that's even more so on the IT side of things than on the OT side of things, but still it's a valid way to look at it. Some bad examples. So for example, let's say I have a 10-floor building and I decide, well, you know what, I'm just going to have 10 VLANs, one for each floor. That doesn't make any sense because on each floor there's going to be devices that need to talk to devices on other floors. So basically you're segregating the traffic per floor, but you still have every single device having to talk across floors. So you're basically going against the concept of VLANs if you do that sort of thing. You definitely want to do it on a per service basis. So what we just did here, we basically created this VLAN 200 here. We're going to go back and create another VLAN for this network. And we've got the capture tool connected into the device here, and that port is currently on VLAN 200. We can switch to 201, which is our other VLAN we created. And we can snoop that traffic as well and show you what that looks like. Okay, so we'll head back to our live demo. So we'll do the second VLAN first.
Those two will be 201.
Yeah. Do we want to switch the capture tool over?
Yep, we do.
Okay. So I am going to do that right now. I'm going to go in and I'm going to flip this capture tool from 103 over to 201. So that's on the second VLAN that we're going to create. We haven't created it yet, but once it's created, this capture tool will be on there. If it's capture running right now, it'll show us going on to a VLAN with no traffic whatsoever on it. So that'll look kind of good.
And we can pick up that IP router on 201 as well.
Yeah, exactly.
Just a quick question I want to get back to here. Someone is asking if are the VLANs on different NICs or should they be on one NIC?
That's a good question. In a perfect world, if you have the NICs available, it's nice to have them on separate NICs. There are setups that do support having VLANs on a single NIC. That can come down to a lot of factors, how you're doing your VLANs, what type of NIC you have. So there's a lot of parameters. So it's a lot simpler to have them on separate NICs, easier just because you can assign it there. But you can definitely have multiple VLANs on a single NIC. It just gets a little bit more advanced, and you have to be aware of what kind of hardware you're using. And especially if you're going to downstream to devices, those devices, if you have 2 or 3 VLANs on a single NIC and you're trying to daisy chain devices, those devices need to be VLAN aware if you're trying to do that. So it can definitely be done. You just have to keep in mind there's some other things to take into consideration with that. Can you, Dave, can you put the BACnet router on 201 for me? Thank you. And so here we're moving everything up to new VLAN, and we've segregated traffic. But what we're going to do now is we're going to say, well, we want to see that traffic come back. We've segregated them, but for some reason we do need them to talk. In fact, we needed them. So we're going to instead of getting rid of the VLANs for this instance, we're going to use a BBMD to bridge traffic across those VLANs. And we're going to show, and then you can see what happens to the traffic once we do that in the capture. So I'll bring it up on my side. And you can see here the IP router now has the new address, and so does the S1000, which is also doing routing for a couple devices. They're not currently talking, and to accomplish that, we need to have BBMDs. And it's important to note, when you look at setting up a BBMD, there can be it can seem a little confusing, but basically there's some easy stuff to remember. And this holds true for our devices, for the router we're going to show you, for Tritium. When you enable BBMD, and let's say I didn't have an entry here. If I enable BBMD, that basically means I'm accepting that traffic. If somebody sends traffic to me, I'm going to rebroadcast it to my network. That's what that means. So as soon as I turn that on, I'm a client. I'm waiting for traffic to come. That's fine. It's just sitting there waiting. If nobody sends it traffic, it's not going to do anything. So having that enabled right now, if nobody's sending me traffic, it won't do a thing. But when it's on and somebody directs traffic towards me, then I'm going to get it. So if we look at the BACnet router, we're going to go ahead and turn that into a BBMD real quick. So we'll turn that on, and let's see if we need to change anything here. Not initially. We'll add a broadcast distribution table entry. We'll add that, but we're going to turn on BBMD. We're going to submit it, and then I'll go ahead and save that on the router. And then here, I need to tell this BBMD, I need to tell it to direct traffic to that one. So I'm going to add an entry. I'm going to add 10.222.201.60, which is the new address for that router. And the subnet mask is 255.255.255.255. And the reason for this is we don't need, the table entry doesn't need to know the entire network. It doesn't care. It's going to direct this traffic towards a single device. And that's basically what this subnet is giving us. We don't care about the rest of it. We don't care if it's a class C or B. We only want this traffic to go here. That's it. So, and then of course the port, very important, 47808. And then you hit OK. And it's worth noting that this port is important because if you have devices on the same subnet, on the same VLAN, but you're using different UDP ports, they're effectively isolated from each other from broadcast traffic. So you'll need to use a BBMD even inside the same subnet, inside the same VLAN, to bridge traffic to the other UDP port. So that's one way to handle that. Not a great design, but if you're stuck with it, that's how you would get traffic from 47808 down to, say, 47809. So we've created this. We'll apply and save these settings. And then we, ideally, now all of the traffic that broadcasts on VLAN 200, which is those ECB 403 and the 203 and the 303 here and the S1000, all four of those controllers, their broadcast traffic will now be sent to VLAN 201. And it will go via this IP router, and it will be rebroadcast. It's one-sided, though, because now, if I want my broadcast traffic from this zone controller, from VLAN 201, I'll need to do the same thing here. I'll need to make an entry into here to create it. So I'll need to create something like 10.222.200.51/32, which is another way of saying 255, 255, 255, 255. So you'll see that coming. And we covered that somewhat in a previous seminar. So, and then our port is 47808. So I'll save that entry and restart. And now we should have, once that router restarts, we should start to see more traffic eventually. Here on our diagnostic utility, we should start to see broadcast traffic from the other network, and they should see broadcast traffic from us, if we haven't screwed it up on our live session here. But that's the gist. Now, while we're waiting for that traffic to kick in, we might discuss real quickly foreign devices. Briefly, foreign devices are utilized in conjunction with BBMDs. So if you have a BBM, let's say you have a foreign device aware device, like an IP controller like these, and I have it on one network by itself, or maybe it's there with two other IP controllers, and they're off in a different building, different VLAN, whatever the case may be, and I want to get data over to where my main network is. I don't need to bridge that entire network. I don't need to do a BBMD all the way over. I can use foreign device instead, which will just take this controller's broadcast traffic and push it onto that BBMD. So, and we may cover this in a later seminar in more detail. Foreign devices can be really useful and should be considered something you should take into consideration when doing large IP networks. Because if I have two VLANs, typically what you'll do is if you have two VLANs and you have 100 IP controls on each, and you need outside air temp over here, what I see a lot of is people just doing a BBMD to get any traffic over, and then they take over a couple of network values they need to the other network, and they're happy. But that's a bit of overkill because now all your broadcast traffic is there. Whereas a foreign device would allow you to broadcast your outside air temp from a single controller, an AHU or a rooftop controller, to multiple VLANs without having all the broadcast traffic from that VLAN go, just that controller's traffic. So foreign devices are really useful and should take advantage. But for the purpose of this discussion, we're kind of looking at a bigger network, so we'll stick with this. So I don't know if we were successful in getting the BBMD to bridge over, but if not, we'll cover it. But hopefully the capture utility will show it. So if we want to see if we can bring that up, maybe take a couple minutes and see if we can load that, Dave.
Sounds good. Okay, I'll just get the screen up here. So it'll update in a second. So we'll once it's loaded, we'll switch over.
I'm not quite sure if I got all of it bridged over. Go ahead.
I was just going to say we kind of skipped our slide for this one, but that's okay.
Let's jump into it real quick before we got carried away.
What I wanted to do was shift back over here to we talked about everything on this slide, but I wanted to look at this one here. So basically, we've got a BBMD here, and we've got a BBMD in this network, and in this VLAN. And so they're broadcasting traffic to each other across the network here. Basically, that's what Robert set up. What we did was we switched this capture tool onto the 201 network. So now we're capturing traffic that's on this network, which we should be able to see at beginning with empty traffic. Then when we added all these devices onto it, we'll see that traffic. And then when Robert added the BBMD in, we'll see some additional broadcast traffic on top of that. So I'll jump back here. It looks like it's in the processing stage, so it should be up there. As soon as that's done, we'll be able to see it. It usually just takes a minute or so to get everything up, so that's why we're waiting. So this will be an interesting one. It should be a nice step function.
I'm
not sure if we got that when we were doing all this live stuff. I'm not sure if we got that BBMD to come across, but it's okay.
Yeah.
While we're waiting for this, I can ask you a couple questions.
Absolutely.
So this one was from earlier on the webinar. Does the VLAN need to exist in the router in order to create it in one view?
No, it doesn't need to exist in the router. It only needs to exist in the router if you're going to do cross-router VLANs. That's something that we did do here. But if all you have is a couple of switches and you have the traffic just going through the switch, you don't need to create a route for it.
Great, thank you.
All right. So here you can see you can see at 907 here we've got just the traffic here, simple traffic, and then we've added additional traffic onto it. I'll switch over to the other view here, which is actually a lot better seeing this. Yeah, so here we go. So we have this traffic here. So the 60 was the one that we moved over first, and then we added in the additional traffic from the 51 and 52 from the broadcast perspective. So it kind of looks like we've gone back to where we started with, and that's the difficult part of doing BBMDs and VLANs is sometimes when you add a VLAN back in, it basically, so when you add a BBMD into the VLAN, it basically takes away everything you did when you segregated the traffic in the first place. So that's why you have to be very careful about using it. If you have, for example, if you do what I mentioned earlier, where you have one VLAN per floor, and then you have a BBMD on every single floor talking to every other floor, all of a sudden you just basically have one network again, and doing the VLANs is pointless. So you want to have as few BBMDs as you can and you want to design your VLANs in a service-oriented way so they don't really need to talk to each other. So I think that was kind of the key takeaway point from that.
Yeah, because if you're designing these networks, you have to take into account subnets, VLANs, your MSTP trunks, BBMDs, foreign devices, supervisory controllers. You have a lot to consider. And so really want to stress when you're designing these networks, don't look at your subnet first, don't look at BBMD first. Look at your mechanical systems and look at what needs to talk and decide on your VLANs first. Figure out what needs to be on the same VLAN and then address your subnets and where you need BBMDs or foreign devices to get the specific data you need across. I really want to stress right here, what we just showed you, it effectively worked. We bridged traffic across VLAN, but we've undone the purpose of having the VLAN. We've basically brought all the traffic back. So you can do it. The question is, at that point though, why have the VLAN? Because you're eliminating some of the benefit. There's still some other benefit to having the VLANs there, but from a BACnet perspective, you've eliminated the benefit for having the VLAN. So you really want to look ahead of time. You say your mechanical systems, and I can't stress enough, don't design your VLANs around your architecture or around a specific number of devices. VLANs, there's other ways to deal with that. Even within the VLAN, you can have multiple subnets and segregate that way. So if you have a building with 600 VAVs and all the VAVs are doing one thing and they all need to talk the same way to the same stuff, you can have a VLAN with just VAVs and have two subnets there. That's fine. It's more important that you use VLANs to segregate those logical groups of controllers and then use subnetting and other tools to break it up further if you need to. That's the important thing to come away with this. And BBMDs, once you've done those two steps, BBMDs and foreign devices are there to help you then get the communication across all of that where you need it. So you use them sparingly, and if you've designed the network well on a big site, yeah, you're probably going to have a couple BBMDs and maybe a few foreign devices. But that's the idea. On a really large site, you've designed it in such a way that you only need, say, maybe a BBMD at the plant controller, and maybe you need some foreign devices up on the roofs with some air handlers and things like that. So BBMDs aren't bad. They're just bad when they're used across a site quite a bit. And if you have a large site and you're starting to get a lot of BBMDs, like 10 or 20 or 30, you really got to rethink that, because you're going to have a hard time troubleshooting issues. And eventually it will easily take down your MSTP trunks. They can be saturated easily. But even on the IP side, we have sites where once you start getting past 12 and 13 and 15 VLANs, you can start taking down the IP side as well. Those controllers can only queue up so much, and so it's really important to look at that from a design standpoint.
Great. So I have some questions here. One from early on in the webinar. Someone was wondering what the difference is between the ECY S1000 and the BBMD, and do they both use IP?
The S1000 is just an IP controller. It also happens, it's powerful enough that it can do some of the jobs of a BACnet router as well. So what you're seeing when you look at the S1000 here is it has an RS-45 port, and it's acting as a BACnet IP router. And if you look here, I can make it a BBMD, but I don't. I have made a separate IP controller on the network, BBMD. And I'm glad someone asked, because let me explain why. If you have two IP controllers on a site, if you can avoid it, it's really nice to not mix your BBMDs and your BACnet routers. It's very hard to do unless you just happen to have, like, a bunch of Eclipse controllers. You can do it. But if you have a choice, it's better to have one device acting as a BBMD and another device acting as a router, especially when those devices are dual purpose and they're also maybe having I/O and controlling things. But generally, a BBMD is a single point of failure. So it may be a critical element in your network. And so you don't want to have to take it down for troubleshooting. If you're just troubleshooting an MSTP bus, if possible. And the less you have that BBMD, the device doing the less things it's doing, the better. It has a big job already if it's trying to route all of that broadcast traffic across these networks. So if you can, and if your architecture supports it, it's better to have a BBMD just do that job I know that's not typical with older systems because you have a router and that's always your BBMD. But now with all these IP devices around, being able to serve dual functions, if I have a few Eclipse controllers, I will always make one Eclipse controller a BBMD and then let the other one do routing, but I'll try not to mix it on that subnet. I'll try to give them separate jobs. And it's really just about spreading the workload, not putting like if I have 4 RS-45 ports on this, and I see this sometimes, you'll go, somebody might have 4 RS-45 ports, 4 different MSTP trunks on this S1000, and then a ton of IO, and it's running a plant or doing something else. And then on top of that, they're going to turn it into a BBMD and just add one more job onto it, plus graphics and everything else. And it can handle that, but it slowly, as you keep adding those things, it's becoming a bigger and bigger single point of failure. So ultimately, on a large network, I would always have one device. If I need a BBMD, I'm just going to add one small device and have it do that job, and that's its job, because it's critical to the network. If the BBMD goes down, you might lose comm across those VLANs entirely, depending on how you're moving traffic. So it's just worth considering when you're designing a system to take a look at that. And you can even put in a router. You can put in an MSTP router with no MSTP trunks, and it can still act as a BBMD on an IP subnet. Most models can handle that. So from a design standpoint, just take a look at that.
Great. So another question, can we set different VLANs for each port on the same C401I?
Yeah, absolutely. Let me go back to one view. So for example, if I had a device in this port here, I can set it to whatever port I want. If I choose to set it to default port, for example, sure enough, I can. Obviously, there's no device on there, but that's okay. And what's going to happen is that anything that is routed to that VLAN that comes into this switch will go to that port only. And anything that is routed to 200 will go to these 2 ports. And that's true for 4 port, 8 port, 16, 24, 48, whatever. Doesn't really matter. Each port has its own VLAN settings.
And just to add on to this question, this is a good question, because when you're designing a site, if you're going to daisy chain a bunch of controllers, and you're looking at cost-wise what it costs to daisy chain those controllers, you're trying to daisy chain as many as you can to save money and use less ports on your switch. But just keep in mind, what you can assign a VLAN per port, but everything daisy chained on that port is now on that VLAN, everything. So when you're looking at how many devices to daisy chain on a port, keep in mind that if there are devices like an air handler or an RTU mixed in with VADs, you may have a reason later to have the VLAN, to have an air handler on a separate VLAN. So you may want to bring down a separate run and give it a separate port. So just keep that in mind when you're deciding how many devices go on a single port, that you make sure that if you're mixing mechanical systems, that you may not want to do that, or you may want to pull a second run to get a second port, because you're locked into that VLAN. So everything on port 103 now, port 3 is now on VLAN 103, and not on the daisy chain, you can't segregate that anymore. They're all there. So.
Great. Another question, in the BBMD scenario where we had MSTP subnets, if I needed to pass, say, a maximum space humidity to my chilled water plant, I could. How would you do this in a VLAN setup?
Well, we would do it. You may need to, depending on how you've isolated your network, you may have to use a foreign device or a BBMD. That's what we're talking about. They're useful tools. So it would depend. Are you having a device go and read that point? Are you broadcasting that value out to the network because multiple controllers can use it? So it comes into how, first of all, how are you consuming that data? Are you sending it, or is it being pulled? Is it a confirmed COV? So you have to look at how you're moving the data, and maybe how you set up your network helps you decide how to move that data. And then you'll have to have a BBMD, or ideally a foreign device. Because if you just have one controller that has one value you need, you really want to set that up as a foreign device and have that go to the BBMD so that only its traffic is sent. And then you can do, say, broadcast that value, which is my personal preference. if I have an important value, I prefer to broadcast it. And the reason for that is if you're likely going to consume that data at the supervisor, you're going to have a graphic, you're going to be displaying it. So there's one point that needs to see that data. And then if you have one or two other controllers that need to see that data, it doesn't make sense to have them all polling one controller just to get the same point when you could broadcast it and they could all consume it at once. So it's more efficient if you're doing one-to-many. If you have many, it's more efficient to do that. That's one of the benefits of BACnet. Take advantage of it. But you would need to make it a foreign device or use a BBMD to accomplish that if you segregate those by VLAN. So keep that in mind. That's one of the things you have to look at your design stage. Does this piece of equipment, does it need to sit on a VLAN with other pieces of equipment? And just because it's in one room, don't let that deter you. If you have 4 controllers in one room and they all need to be on different VLANs, pull 4 Cat5 cables. I mean, it's more costly initially, but from a network performance standpoint, from a configuration standpoint, and in the long run, from a troubleshooting and stability standpoint, it's gonna be far more cost effective. I help a lot of people and spend a lot of man hours troubleshooting stuff, and we all know how expensive a controls tech is as far as man hours are concerned. And a few hours of a control tech's time is easily, you've just wasted $500. So keep that in mind when you're looking at this stuff. Don't create a scenario trying to save $2 on a few Cat5 cables when you can avoid that kind of scenario up front. But yeah, ultimately, if you have a value that's on a separate VLAN, with BACnet, you will need to use a foreign device or a BBMD or a supervisory controller, some way to map that over to that other network.
Great.
Yeah, and just to reiterate, we're advising and advocating the use of VLANs, but BBMDs are still useful and have a purpose within that. We just want to make sure they're not counteracting each other all the time.
Okay, can you not set up VLANs on layer 2 so you don't need a BBMD? And then part of that is there's a comment that there's other providers that have secure VPNs that will communicate over layer 2.
That's a great question. And that is absolutely, that can be done. You can do layer 2 VPNs. I've done them myself. I've even bridged networks with layer 2 VPNs, and it does work. You can have that broadcast traffic come over. You can depending on your manufacturer and depending on how you set up your rules on your VLANs, you can potentially move broadcast traffic across VLANs. This is so, but not only do those setups get to be more advanced, you still ultimately have the same downsides. When you're not currently watching that network, when you're not managing it, it's very easy for something to go wrong or someone to work on it. And now, since they're not segregated, if somebody does something dumb, and over the course of time, somebody will, you can take down a larger segment of the network. So I have done that. I have bridged networks with layer 2 and had devices in different parts of the country able to talk to each other on the same VLAN and broadcast to each other on. No problem. You can do that. It's a little bit more advanced, and you can always call and talk to me or Optigo about it, but it's a little bit easier to do it with a BBMD because it's an entry, and it's a little bit easier to control. But if you're comfortable at layer 2 and you're comfortable with setting up those types of VPNs, yes, that setup can and will work for you.
Great. Well, any other questions we will get back to individually, but I think that's our time for the webinar. So Dave and Robert, thank you so much for your time today. And if anyone has more questions, feel free to email them over and we will get back to them as soon as we can.
All right.
Thanks again. Thank you. Have a good day.
Thank you.